Hi all. Today we'll be discussing about disaccharides and we'll take two examples of disaccharides to explain you all about the glycosidic bonds. So basically that day we have seen what is disaccharides. So disaccharides means two molecules of monosaccharides. So it means the two molecules of monosaccharides so when we say two molecules of monosaccharides, so they can be same or different. So what I mean is it can be two molecules of monosaccharides. So monosaccharides can be either same molecule or of the different monosaccharides. So it may be either of suppose for example in maltose, so it will be two units of glucose bind to form maltose, while when I say it's different, that means it's for example if we take here it's sucrose, so which means it's a combination of glucose and fructose. So we'll take one example here first to see the same monosaccharides. So here the first example is the maltose. Maltose, so which is also called as the malt sugar. Okay, so when we say maltose, it means the two molecules of glucose are bind together. So first let us see the formula of glucose. So glucose, it's written as C6H12 and O6. So let's draw the ring structure of this. Okay, now let's see how the one glucose molecule is bonded with the second glucose molecule by a glycosidic bond. So first let us draw the ring structure of this. So here we'll be drawing the hexagonal structure. So here this is O. So this is the hexagonal ring, and here we'll number the carbon atoms. So this is the first carbon, second carbon, third carbon, fourth, fifth and sixth. Okay, so we'll just draw it here. Suppose here this one is C, and here it's OH group, here it's hydrogen, and here again it's hydrogen, OH group, hydrogen, here again HO, hydrogen, and here again hydrogen, and this is written as CH2OH. Okay, so we'll see how this, so this is one glucose molecule we've drawn here, the ring structure of glucose. So here we'll be drawing another glucose structure. So again the same, C H, here it will be HO, H, OH, H, here is the H and CH2OH. Okay, so now what do you see here? So this is the second glucose molecule. So now here we can see that the glucose, one carbon of first glucose, it has a bond with the fourth carbon of the another glucose. So here we know this is first, second, third, fourth carbon. Okay, so here we can see first is first carbon of first glucose, and the second is the fourth carbon of the second glucose forms the glycosidic bond. Therefore, it's called as 1,4-glycosidic bond. So in this way we can see how in disaccharides one glucose, there are two molecules, but they are bound together by a glycosidic bond. So we have seen here how the two glucose molecules, so one glucose, it binds with the another glucose with the 1,4-glycosidic bond. So now here, as we can see, in the first glucose, the aldehyde group CHO is lost. Therefore, it's reduced. CHO is reduced, while in the second group, the CHO group is, it's there, it's not reduced. So at least one aldehyde group remains. So in this, the aldehyde group remains. Therefore, we say maltose is a reducing sugar. Okay, so maltose is a reducing sugar because even if one aldehyde group of one glucose is reduced, the another group of the glucose, another aldehyde group of the glucose remains, and only the hydroxyl group is reduced here. Therefore, it's called as the reducing sugar. So now let us see the second example, that is the sucrose. Okay. So sucrose is made up of one molecule of glucose and second molecule of fructose. Okay, so let us draw the glucose structure once again. So like we have seen, the ring structure is so one carbon, second carbon, third carbon, fourth carbon, fifth, and then the sixth. And so here we'll draw the fructose. So fructose is written as so now here is named as first carbon, second carbon, third carbon, fourth carbon, and fifth. So now we can see here the bond is, this is glucose. So the first carbon of the glucose and the second carbon of the fructose. So here the bond is 1,2-glycosidic bond. But here we have seen, okay, so here we see that the first carbon, so here the CHO, that is the carbonyl group, which we say as the aldehyde, carbonyl group is reduced. Therefore, this is reduced, shows the reduction. So in fructose we can see that the functional group, that is the CO, or the ketone group is reduced. So in both, either in the glucose as well as in the fructose, the aldehyde as well as the ketone group is reduced. Therefore, we can say that it's, as both the functional groups, aldehyde as well as the ketones, are reduced, therefore it's called as the non-reducing sugar, the different monosaccharides. I hope you all like this video, and If you please like this video, kindly share and please subscribe. Thank you.